Hello and welcome to Chapter 1, Section 4. This is on reasoning and proof. And there are two kinds of reasoning. There is inductive reasoning and deductive reasoning. Inductive means the rule is true because specific cases are true. I can say that all cars have four wheels because every single car I've ever seen has four wheels. Deductive reasoning uses logic to draw conclusions. That says that all squares have four sides because it's part of the definition of a square to have four sides. Both inductive and deductive can be used to prove a conjecture. A conjecture is a statement believed to be true. So let's look at this conjecture. The book wants us to add three consecutive counting numbers. So if we added 1 plus 2 plus 3, we get 6. And the question is that divisible by 3? Well, 6 divided by 3, yes, that is divisible. We're going to do the next three numbers starting with 2. 2 plus 3 plus 4 is 9. Is that divisible by 3? Yes. So the conjecture is that the sum of three consecutive counting numbers is always divisible by 3. Now, is this inductive reasoning or deductive reasoning? Did we use specific cases or did we use logic? This was specific cases. We said it works with 1, 2, 3, and we said it works with 2, 3, 4, and we decided it's going to work on everything. Can we come up with a counterexample? A theorem is a statement you can prove using logical steps. So let's look at this three consecutive numbers problem from a logical steps point of view. We're going to have three numbers, and our first number is going to be n. And then our second number is going to be n plus 1, and our third number is going to be n plus 2. And we can stick any number in for n, and if we add 1, it's going to be the next number. And if we add 2 to this number, it's going to be the next number. So this works. And the sum of these three numbers is n plus 1 plus n plus 2. And that's going to give us three n's and three numbers, 3n plus 3. Now, if we factor the 3 out, we can pull the 3 out of both of them and say it's 3 times n plus 1. Now what we've proven is that this is divisible by 3. It doesn't matter what n is. We can divide by 3, and those will cancel out. So what we've just decided is that the conjecture that we were just asking is true, because we can now prove it using logical steps, math. All right, try the reflection questions, numbers 1 and 2 on page 46. Pause here and come back when you're done. Number 1 was inductive because we used specific cases, not rules. And number 2 is no. If it's not acute, it doesn't mean it has to be obtuse. It could be right, or it could be straight, or it could be obtuse. But we don't know it for sure. Next, we're going to look at proofs, but we're first going to look at conditional statements, and those are if P, then Q. If we have something, then something else. So P is always the hypothesis, and Q is the conclusion. So for an example in math, if 3x minus 5 equals 13, then x equals 6, and we can work mathematically, we can work that out to prove that that's true. And if 3x plus 5 equals something else, then x doesn't equal 6. X is going to equal something else. Now, the next thing they show you is the big list of properties of equalities on the bottom of page 46. Please take a minute to look through those. And those are all condition statements. If you have this, then it means this. And they all have names. When we do proofs, we use deductive reasoning and we justify each step. We use rules to say that things can work or can't. Not just, I've never seen a three-wheeled car, but there are actually rules to this. So to start with, we're going to use the properties of equality as justifications. All of these properties from this list. So we're going to start with 14 equals 3x minus 4. And we know that the first thing that we would do in algebra is we would add 4 to both sides. And when we do that, we end up with 18 equals 3x. But we do that because of the addition property of equality. Because it says that whatever we add to one side, we add to the other side because there's an equal sign. So we're going to get really good at remembering all of these names. When we're doing a proof, we go step by step and we have to justify why we think we can do that. The next thing I would do is divide each side by 3, and that's the division property of equality. And luckily the properties of equality are really easy to remember. And I end up with 6 equals x. But I really want, they take this one step too far, I think. I really want it to say x equals 6. And I know that x equals 6 and 6 equals x is the same because of the symmetric property of equality. So all of these together is a proof for this algebra issue, this conditional statement. Okay? Pause here and try the next one by yourself and come back when you're done. So with B, 9 equals 17 minus 4x, we use the subtraction property of equality to subtract 17 from both sides, and the division property of equality to divide each side by negative 4, and the symmetrical property of equality to decide that x equals 2. How'd you do? Now the next bit I learned a little bit differently than you, and so I'm going to teach it the way I was taught it to start with. And this is a little more visual, and I apparently am a visual learner, so I'm hoping that if you are a visual learner, this will help you too. Let's say that this circle represents all the shapes in the world, and any shape that you can come up with, we would put in this circle. And everything that's not in this circle are lines and points and marks and squiggles and circle. Well, nope, circles are in here because that's a shape. Anything that doesn't have two closed points are shapes. And inside the universe of all shapes, there is another circle, another area that is polygons. And those are shapes with straight sides. So everything that's not in polygons would be spheres and cone and circle and anything with curved edges. But if it's got all straight sides, they're polygons. And then I've got this section over here that is all quadrilaterals, which are four-sided figures. And then part of my quadrilaterals would be rectangles. Now what I'd like you to do is realize that if you have a rectangle, then you also have a quadrilateral. Because all the rectangles are quadrilaterals. If you have a rectangle, then you have a polygon. Because all rectangles are inside polygons. What I can't say is if I have a polygon, then I have a rectangle. Because I could have something over here that is that's a triangle. Because it's a polygon because it's got straight sides, but it's not a rectangle. So I can't say if I have a polygon, then I have a rectangle, but I can say if I have a rectangle, then I have a polygon. So direction matters here. Some of the questions that you're about to look at ask you for conceptual ideas. And this little schematic has always helped me figure that out. So I'm asking you to pause here, try your turn numbers 3 through 6, and come back when you're done. So for number 3, if an animal is a zebra, then it belongs to the genus Equus. And number 4, if the bill gets 2/3 of the vote in the Senate, then it will pass. And number 5, we subtracted 3 from both sides using the subtraction property of equality, and we divided by -4 using the division property of equality, and we ended up with x equal 2. And for number 6, the 4 are multiplication, symmetric, substitution, and transitive. So our next trick is going to be using postulates about segments and angles. So we're good at using proofs with properties of equality. Let's move on. We have what we call the linear pair theorem. If two angles, so there's a pair of them, form a linear pair, remember linear means make a line, and we've made a line here, then they are supplementary. And supplementary means that they equal 180 degrees. And complementary means they make 90 degrees. Remember those words from, what, 7th grade math? The linear pair theorem says that the measure of angle 3 plus the measure of angle 4 equals 180 degrees if they are a linear pair, which means that the two outside sides of the angles make a line. So the linear pair theorem and the segment addition postulate, which we had on page 7, and the angle addition postulate, which we had on page 22, are more justifications we can use for proofs as we move through. Example 1 gives us line RST, where RS is x plus 2 and ST is 3x minus 8, and the whole thing is 5x minus 12. And it asks us to use a postulate or theorem to find the value of x. Well, this is kind of the poster child for the segment addition postulate, saying that RS plus ST equals RT. And when we substitute the lengths in for the segments, that's the substitution property of equality, and then we add these guys together, and then we subtract 4x from both sides, which is subtraction property, and then we add 12 to both sides, and we end up with 6 equals x, and we switch it around to x equals 6 to get symmetry. So this is how we use this postulate to justify what we do here to solve for x. Please pause here to use this logic and apply it to angles on page 49, and come back when you're done. So B gave us 2 conjoined angles, and it told us that the measure of the largest angle is 15x minus 10, and it wants us to solve for x. So we're using the angle addition postulate, saying that RSP plus PST equals RST, and that's the angle addition postulate. And so we substituted in the numbers, we added these together, we added and subtracted on both sides, we divided by 9, and we ended up with x equals 5. Pause here to do reflection number 7 and your turn number 8. Come back when you're done.